Now let us look at the proof of associativity for rational numbers under the operation of multiplication. So we proceed as we did earlier when we were trying to prove addition and subtraction. We take three numbers, three rational numbers a, b and c, and we first multiply ab. That is, we have the first product by grouping a and b together first, and then we multiply this product with c. So the three numbers that we have is minus of 7 by 3 multiplied by 5 by 4 multiplied by 2 by 9, as is shown over here. Now when we simplify this, that is, we simply multiply minus 7 with minus 5 and we multiply 3 with 4, so we get minus 35 by 12, and then we carry over this minus 2 by 9 or the plus 2 by 9 to here. Then we proceed in a similar way, so we can actually simplify this further because you have 2 over here and this is 12, so you can 2 cancel it. So this is 2 times 1 is 2 and 2 times 6 is 12. When you simplify this, we get minus 35 by 54. So this is the result of multiplying a cross a by b first and then multiplying the product by c. Now let us look at what happens when we group b and c first, as is shown over here. Now same numbers, so here we have 7 by 3 multiplied by 5 by 4 multiplied by 2 by 9. So when I solve this over here, the product of b into c is 5 by 18, as shown over here. Again, we have simplified. 2 times 1 is 2 and 2 times 2 gives me 4, so we have done that simplification, and that's how we got 5 by 18. Now we carry this 7 by 3, which is a, over here, and to complete our operation of multiplication. So when we further do this multiplication, we get minus of 35 by 54. It's straightforward. Multiply the numerators and the denominators and we get it over here. So what do you say about the final result? You can say that in both the cases we have got the same result, and this will be true for any three rational numbers. Again, a good idea would be to take any three rational numbers and see if you can prove it for yourself, this property. So we say that for all the rational numbers, the commutative property is observed, or commutative property, or the associative property holds true under multiplication. So that is it. Now let us look at division. So it is going to be a little bit tricky, but we will see how do we work step by step. So we follow the same method. We take three numbers a, b and c, and we first divide a by b, and then we divide this, the result of this, with c. So let's say that the two numbers I have taken as a is plus of 1 by 2 divided by minus of 1 by 2, and then c is 2 by 5. So as we have discussed earlier, we convert the division into multiplication by changing the numerator and denominator. So what we have over here is 1 by 2 multiplied by minus of 2 by 1. So the 2 gets cancelled out over here and we have just 1. So you have to remember that this is a negative sign. So we have minus 1 divided by 2 by 5. Again, we apply the same operation of converting this into a multiplication by exchanging the numerator and denominator over here. So we get minus 1 multiplied by 5 by 2. You can see this 5, which was a denominator, has become a numerator, and this 2, which was a numerator, has become a denominator. So we get the result of this as minus 5 by 2, which is shown over here. Now let us do this division the other way around. That is, let's first compute the division of b by c and then divide this with a. So in this case, you can see that I have grouped minus 1 by 2 divided by 2 by 5. Proceeding in the same way as we did earlier, converting it into a multiplication sum. So we just exchange the numerators and denominators, and then we multiply both the numerators and denominators. We get minus 5 by 4. So this is actually b divided by c. This is what we get for b divided by c, and this is our a. So now we are going to do a divided by this thing. Same thing converted into multiplication. When we simplify it, we get minus 1 by 5. So now if we were to look at the result that we got for the first part, wherein we grouped A, we first did A divided by B, you can see that these two numbers, minus 5 by 2 and 1 by 5, these two, they are not equal. And therefore, this is a sufficient condition for us to say that the rational numbers are not associative under the operation of division. So that was our discussion on proving the associativity for rational numbers under the operations of multiplication and division.